Hello, my name is Kemi Mary Jones. I'm going to discuss with you today adapter design pattern. Alright, so before we discuss adapter design pattern, let's understand a few concepts about software design pattern. So what is software design pattern? Okay, so software design pattern can be described as a general solution and a reusable one which can help you to solve a common reoccurring problem in your application or system. So, for example, you want to build a house, you will go to the architect and you ask for a blueprint of the design of your house. So, for example, let's say you got the blueprint and you designed your house and you built the house from the design. Okay, so software design pattern is just like your blueprint for your codes, which can be customized and be used to solve general or common types of or a particular recurring problems in your code. So we have different types of software design pattern. We have a behavioral pattern. Okay, behavioral pattern deals with the communication between objects and as well the way responsibility are assigned between objects in a class. Okay, we talk about a creational pattern. Creational pattern, according to its name, has to do with object creation or initialization, and also are like a rule guiding how the objects are created in a given code or situation or in a class. Okay, for example, we want to create a software. So your software have to have a certain rules guiding the app you're creating. So this is how we get to explain a creational pattern. Okay, all right, let's talk about structural pattern. Structural pattern has to do with the composition of the class and the objects, and also the way the objects are assembled in a class into larger structures to create a kind of a design or a software. All right, so we are going to discuss about a conceptual diagram illustrating a design pattern. So as we are talking, we want to discuss about adapter design pattern. So adapter design pattern is an example of a structural design pattern. Here we want to talk about what are the importance of design pattern. Okay, why do we need to have a design pattern when we are creating our software or our app? We have one of the importance of having a design pattern is to solve or have a valid and reliable solution to solve common and recurring problems when we are coding or doing a software design. And moreover, because you have a working solution that has to do with general problems, you tend to save time when you are designing a new or another type of um, design or app. As well, you have the opportunity to reuse this solution created during a design pattern, and also these solutions are flexible and can solve any kind of problem. So therefore, you optimize your code, therefore reducing the size of code you write every time you use this design pattern. However, design patterns are meaningful codes, and they make your coding or your design more neater and attractive. Okay, all right. So now let's ask ourselves this question: what is an adapted design pattern? Okay, let's take for example an adapter plug. You have a two-prong adapter plug and you want to plug it to the wall socket, but the wall socket has a square interface. Therefore, the adapter plug prongs is having a different interface with your wall socket. Therefore, you need a kind of a bridge or a connector that can help you to connect your plug to the wall socket. Therefore, you get yourself a connecting socket. So, an adapter design pattern means a kind of a bridge that or a connector that connects a class with a different interface to another class with a different interface, thereby creating a kind of a connection between both incompatible interface, and as well making them to work together as one. All right, so how does an adapter design pattern works? Okay, I'm going to show you the UML of an adapter design pattern, how it works. So when you see this is your client, which is requesting from the target, but the problem here is the client has a different interface and your target has a different interface. So how do you connect both? Okay, so you need an adapter class. An adapter class has to take a request from kind of a blueprint interface, which we call an adaptee. So the adapter asks a specific request from the adaptee, which it extracts from that common interface, which is the solution, and as well feed it back to the target, therefore acting as a connection between the client, which has a different interface, and the target. Okay, let's see a more realistic example of what I'm trying to explain here. Okay, so we have a plug here, which is our client and asking for original request from the adapter, which converts the request and from the socket itself. So when you look at it, the client is requesting from the adapter, and the adapter is requesting from the interface. So these two interfaces are different. So therefore, the adapter is acting as a bridge connecting what? The client to the adaptee. Therefore, you have a general solution. So we have different ways of implementing an adapter design. We have a class adapter pattern design. So you can implement an adapter design through the class. So whereby the class implements a target interface, you see, it implements the target interface, and therefore the adapter class inherits from the adaptee here. Therefore, the adapter is actually inheriting from the adaptee as well as also implementing what the target interface. So we'll see how this works. So we're going to use C# as a code case study here. So we have an example of a company that has a number of employees. This is their HR wanting to have a kind of a billing system or a salary system for the employee. So the first thing for you to create a class adapter is by first creating what the class itself. So here we create the employee class and we initialize it with a get and setter, and also we have a constructor. Okay, then the next step is to create your adaptee class, which is the billing system itself. So the HR system is having a different interface compared to the billing system, but we want to have both interface or classes working together so that the HR can see the salaries of the employees in the company. So here is the adaptee which we have created here. So, and we created a method that takes a list as a parameter, as you can see here, of the employees in the company. Therefore, the next thing we do here is to create a target interface where we are going to be pulling the employee salary from. Okay, so this is an array of employee and their salaries here. The next thing we do is to create the adapter itself, which is the connector, which is the bridge between the HR employee system and the billing system we want to incorporate into the HR employee existing employee system. So here we create a list. We are initializing the employee list and populating it with values. So this adapter is what is going to feed information to the HR system itself. Then we now have to run the code we've created, which is our client. Remember, your main method is the entry point. The entry point of the code is the client, where the code is requesting for information. And here, the only thing we do is to display the employee information with their salary. So this is how to create a class adapter using C#. The same thing goes for Java, just a few differences. Okay. All right, so the next thing is we want to see how we create an object adapter pattern. All right, the object adapter pattern is just a little bit different from the class adapter pattern, because the object adapter delegates to an adaptee object. It also asks or requests a reference to the adaptee class, and also called the adaptee method. So the adapter has a reference to the adaptee class. However, it's also calling the adaptee what? Methods to implement in the target, which is an interface. Okay. All right. So the same thing goes with the creation of object adapter. The same steps. You create a class, an employee class, a getter, a setter, and a constructor. Then the next thing, you create your adaptee, which is the billing system, and you create a list of parameters of the employees as well. The next thing, you create your target interface. But the only difference here you see, when you look at the object adapter class, you see that the adapter class is only implementing the target interface. All right. While in the class adapter design, you see that the class adapter is implementing the target interface as well as the billing system. Okay, so that's the difference between both. And then the next thing, you display the information through the client, which is through the entry point, the main method. All right, this is all about the concept of adapter design, and I hope this gives you a more insight on how adapter design works. All right, so let's just have a summary of what we have learned today. So we have a difference between class adapter and object adapter. You must know that the class adapter uses inheritance and also wrap a class. Okay, and the object adapter uses composition and can wrap classes or interface. Okay, so the class adapter can use multiple inheritance to adapt one interface to another, but you must understand this multiple inheritance is not supported by Java and C#, but every other programming language allows this, while object adapter does not. Okay, thank you very much, everyone. So this serve as the end of today's lecture. Thank you. I am Kemi Mary Jones.